How you doing, everybody? Randy and Richard in the shop, and today we're going to make a base plate, an adapter plate, so I can fit the Wilton Vise that we did modified in the previous video. Be sure to check that out, so we can put it on the welding table. So what we're going to do here, this is a piece of 836 donated by Eric Richards of Turner Tooling up in the San Francisco Bay Area. He was very kind to donated me a disc of 836. It's a little over 1.8 inches thick, 6 inches in diameter. Make sure this is kind of squared up here on the lathe. I just kind of threw it in here. You know, when you're doing something like this and your jaws chucks are out, watch your speeds and make sure you have clearance on your lathe, obviously, but watch your hands. These are very dangerous. You don't want to get hit by this. You don't want to run your tools into it. Very dangerous thing, but awareness is such a high part of safety that it eliminates a lot of accidents just because of the awareness of what is going on and how you're doing it. So don't be disturbed when you're doing stuff like this, and stop the machine. Don't walk away from it. Things like that. Like I said, so we're going to face this off. We're going to put a center hole in it. Precision center hole I want in this because the vise has a hole in it. The holes that were done in the vise were very nicely done, and so they're fairly precise. So we're going to have a center pin for rotation and a bunch of holes so we can turn the vise. Over the Christmas holiday, a viewer asked if I could make him one of these dual holders, indicator holders, like Mr. Pete made. Well, I told him it cost him a fortune if I had to machine one. There's a lot of work in this, and you know, somebody's going to pay you to make one of these. Well, it's just not worth it. You either make it yourself or have a really nice friend, I guess. But I told him what I would do though is design one for 3D printing. This one here is a CXA. So what I did is I designed them in AXA, BXA, and CXA. It has a CXA into the print, and I worked on the prints and got them, you know, so they fit on the holders. I mean, this was several prints of, you know, getting the sizing just right and all that stuff. And I used these small Shars indicators. These things are about $15 to $17 a piece. They're not too bad. There's a guy on eBay, actually, that has a Shars store. He's the only one, supposedly, that's allowed by Shars, and he offers things at a discount. And if you go there, you can get these about $14, $15 a piece. And what I did is I put a flathead socket screw through here and a lock nut, a nylock, thin lock nut, and I've offset them so I can keep this short. I didn't want the tool holder to be too long, so they're offset in height, which is really not a big deal, so they don't hit each other. And I put a threaded hole in here. Now it's 3D printed thread, but if you just run a tap in it, or if you just run your stud in there, it'll be just nice and tight. For a height adjuster, I just haven't made one yet here. If you follow me on Instagram, I posted a picture of one for my son. I made him one with a height adjustment and all that. You really don't need it. You can just throw it on there. But anyway, these actually work pretty good. So let's see, I think Brad Jacob asked does it flex? Well, yeah, it flexes a little bit if you lock it down too hard, or if you just lock it. But once it's in place, it doesn't flex when you're measuring. It actually works really good. I want to say about 4 or 5 hours to print. I printed them out of ABS. They go right on, and you can just barely cinch it, and it's in there solid. But you can just run it right up, eyeball the center height, you know, wherever you want it there, and you're good to go. This is a pretty rough surface here. It's mill scale, so we'll just kind of see how this is. I'm going to show you another thing here real quick. This is something I made up a few years ago. It has a brass end on it, and it has a UHMW end on it. This is my knocker I use. It's made of steel. You don't see the joints. There's a joint in it, but what I did is inside here is lead shot and a little oil for knocking things. I made it a dead blow. This works really good. Really pretty easy to make. Maybe I'll do a video on making one of these. It's big as my fist. So about 1 inch in diameter. If you're interested in that. See how bad this is here. Less than 10. There was 2 or 3 out there now, not too bad. Make sure good and tight. So we'll just call that good. So this goes on both ways. You know, this is for over on this way if you want to check a measurement this way. I'm just real light cut, but I'm cleaning it up, so I wasn't very far off, only a few thousandths. Well, that cleaned up really, really nice. That just turned out beautiful. I'm going to turn a little bit down here just to get a machine surface that's concentric. And then so we have something to grab onto when we flip it around to do the other side. We have a indicator here on the ways to make sure I don't go very far, right? Because of clearance here of the chuck and the carriage. And we have enough room to pass through, and we'll go right to 0. And I'm just clear on my compound. Actually, what I'm going to do is I'm going to crank my compound over. We'll do that, and that will give me a little more carriage clearance to just pass through right there, and we'll reset this. That gives me carriage clearance, but I'm really tight here on this here because of the boring bar length. We'll just take a little bit off as a gauging cut and then measure and see how we need to proceed. There, I can stop right at 0, which is kind of nice. I can see what's going on, and we're good. Oh yeah, nice finish. Now I'm using a Bokum boring bar on this. We're at 489. So we need 11 thousandths total come off. So about 5.5 and see what happens. That's a 5. Oh, that's a nice fit. Nice. This is my pin. It's a tiny, a few tenths over 5. And that's just right. That will work. So I can, this way, it goes in there deep enough. It only needs to go about halfway. On the other side, it's going to be a 5/8 pin. So I'll be just fine. I can just put that pin in there and pretty much probably stay there for the rest of its life. I really don't need to secure it, if we put it that way. I might just Loctite it into this though. Perfect. Using gauge pins to do this really helps a lot. It gives you seems like a much more accurate way to measure that hole using a gauge pin. For all these small holes, that's what I use now is gauge pins. All right, now I'm going to take this out and flip it over, and we'll do the rest of the cleanup. And we're going to put a 5/8 hole on the other side. Another use of my Fireball setup blocks. Now these are magnetic, so nice and clean, and they're very precise. I haven't measured them, but they are right. I measured a couple of them, and they were right on the money. So I'm going to put 3 of those in, and they stick to the chuck, so they don't want to really fall out, which is really good, because I only have one spot on this chuck to tighten or loosen it. Feel them, see if they're all about the same as far as that goes, and that they feel good. Then we can slip them right out. Do the roughness. I would say we're about 5 thousandths out. Now, because I'm only holding on to it by about 1/4 of an inch, so I'm taking fairly light cuts. This is only about 10,000 depth of cut. Side, I just finished boring that out. I just bored this out to the 5/8. 625 fits perfect in there. This one's a smidge under 625, and it just slides right in, just a piston fit. So that'll be good. If I ever wanted to replace it with a dowel pin, something harder, I could. It would just go in there real nice, you know. So I like that. All right, I got my little pallet in here. I just put an index mark on there. I have put an index mark on the edge here. This is the bottom side. I have a stud mounted in here, which is exactly 1/2 inch, and it fits on there just absolutely perfect. We're going to line those two up like so. A couple washers. Grip. It will get this aligned. So this is bolted down, right? And my index mark is there. And I just centered it up with my indicator around here. So we're at 0. So that means we're concentric with the center. And we're going to drill 2 holes there and there. That's about it. And tap them. Halfway through the material. So this is my indicator I use to sweep things with and to indicate on the mill. I took a small R Noga and I put a 1/4 inch rod on it. I took it off the base, and I can put it in the collet up in here for sweeping, and I can stick it up in the little holder on the side of the mill spindle for fixed measurements, right? And it's very versatile. It's nice and easy to move. It works great. And it has a dovetail, so this is all really rigid. And this is a Mitutoyo test indicator. Anyway, this setup works really well. So I just moved 2 inches over. I'm going to drill there. And then I'll go 4 inches over and drill over here, 2 inches from the other side. And that will be it for the bottom. Now I made a couple special shoulder reduced shanked bolts. Let's call them reduced shank bolts. Now these will hold it to the table from underneath, but they'll retain in the holes. And I just want to make sure they go all the way down. And they do, and the threads are below the surface. That's perfect. Yep. All right, we're ready to flip this over. We have 8 holes to do on the other side. Now 2 of the holes are going to kind of half intersect with these 2 holes. It's just the way it is. It's not too bad, but we're only going about half the depth again on the other side. All right, this is my DRO on the mill here. I just have a 2-axis one. DROs are really nice because most of them today all have nice fancy functions. Like this one here, this is a bolt circle. Now, I'm going to zero this out. I'm on the center of the workpiece. And so we'll just zero it out. We're in incremental mode versus ABS mode. And we're going to do a bolt circle. Center will be 0, 0. The diameter is 4.325. Number of holes will be 8. Starting angle is going to be 0. Ending angle will be 0. And we're set. It's pretty simple. And now this is hole number 1, and then we'll just cycle through, and that's position. Just all I have to do is move it till they both read 0, 0. And number 2, move to that one, 3, 4, 5, and 6, 7, and 8. We'll just start at number 1. Is moving the X position down to 0, right there, and drill our hole. Now that looks pretty dang nice. Came out great. Let's get it off of there and test her out. Now this would not have been enough to hold that during milling operations. I wouldn't have tried milling, but drilling is really not a big deal. I can just unscrew the stud. Maybe. There we go. Just unscrew this. There we go. There's the top. The vise will sit on this side, and this is the bottom. It mounts on the table. This is the bottom of the welding table. This is the angle lock mechanism with the new ratchet on here for the lock, right? These here studs are solid copper bolts and nuts, and this one is the grounding lead. I can directly connect my grounding lead right to that from the welder, so it's nice and easy. And this is just a stud if I wanted to hook a clamp ground on. These are the screws for connecting the vise to the table, and these are just socket heads, half 13 cap screws. I turned down the center portion, so when you screw them in, they are self-capturing and they won't fall out, right? And on the top, they are below the surface, so they can just hang out in any holes, and I don't have to keep them somewhere special or something if I don't have the vise on here. They can just hanging out from the bottom of the table. We'll just slip those in so they're ready to go. Now we'll fold the table up just like that. Cinch down the lock. We're good to go. Now for the new vise setup, here's the disc or the puck. Some people call it, or but so I made 2 pins. This bottom has a 5/8 pin, and I'm probably going to end up Loctiting these in, but they're really nice fits. And then the top has a 1/2-inch pin. So the 5/8 pin will go in the holes. Now I put my bolts right here, my 2 bolts, right, and they'll go in the 2 holes in the bottom. Drop it in a hole, and those line up in the bottom, just like that. And all you'll need is now this is a really long one, but a 3/8 Allen wrench, tighten those up. And then here's the top. Here's the vise for the top. Now, like I said, they did a really nice job on these holes here, and they're even and everything. And they did a real good job here. So the fit is just right. And the holes are 90 degrees, of course, and 45. So every 45 degrees. That'll just drop on there, and you can spin it around. 2 1/2-inch 13 socket head cap screws. Drop them in, and you can lock that in place. So this is plenty over the edge here, out here on the side, but you can put it in any one of those holes. That might not be the best choice. I shouldn't say anywhere, due to other things on the bottom, like right here, the base is kind of in the way. But, you know, here, we'll put it over there. Pretty much anywhere else. And where the angle adjuster attaches. So there's a few spots you can't quite do this. Pretty much anywhere. And then the nice thing too, though, is you can set this at an angle if you wanted to the table. I'm thinking of putting flats on this in alignment with the holes, so you could put a square up against the edge of the table, and you could square to the table. So when you turn it for 45, it's going to be 45. So it comes in a nice alignment. And then why we put the new shaft and everything in, so I could have a socket drive, and I just any 3/4 socket, and we can, you know, put a ratchet on there, put an impact on there, whatever we need to do to make that operate like that. But it's over the table and not in the way. So that's the idea. So that's about it, you guys, for the welding table for now, at least. I might come up with some more ideas or something, but right now, like this, we're gonna end on this project. I am thinking about it, making it so it rotates still. So, and how I'm going to do that. And I could leave everything on there. Anyway, we can just fold it down. We can leave all that stuff on there, except for things slide right off. Then it can be up and ready to go. There's the welding table build. Thank you, guys, and thanks for watching. You know, for projects like this, to support projects like this, you know, it helps buying my tools. It helps buying the swag. You know, if you want to become a patron, which is really nice, you know, so I can build my addition on the shop, I would appreciate the help always, but that's what we can support projects like this. So thank you, guys, and thanks for watching.